Hello everyone. In this video, we are going to see the MATLAB simulation of dual converter in non-circulating current mode. Open MATLAB and open Simulink. Create a blank model. We are going to construct the dual converter, non-circulating current mode dual converter, whose circuit will be like this. A dual converter is a 4-quadrant converter, which is constructed by using two full converters that are connected in anti-parallel, and the load is connected in between them. There are two types of dual converter. One is the non-circulating current mode dual converter, and the another one is the circulating current mode converter. That is, the dual converter can be operated either in one of the two modes, circulating current mode or non-circulating current mode. We are going to see the simulation of non-circulating current mode of dual converter. So to construct the dual converter, we need to use two full converters, and we need to connect the two converters in the anti-parallel mode. In non-circulating current mode dual converter, at one particular time, only one converter will be in operation. When the converter 1 is in operation, the converter 2 will not be operating. When the converter 2 is in operation, the converter 1 will not be operating. But in circulating current mode converter, both the currents can be operated at the same time. And in order to limit the current within this loop, we will be having a reactor, which is provided to limit the current. But this configuration is nothing but non-circulating current mode dual converter. We will be constructing this converter in the MATLAB, and we will simulate it. So let us start constructing. So we have to use 4 thyristors to construct the first converter. Control R to rotate the thyristor. We will be using 4 thyristors to construct the first converter. Let us name the switches like thyristor 1, V3, V2, and D4. So the thyristors are connected to form the bridge. We need to connect the AC voltage source at the input side of the converter. Double click on the AC voltage source. Let us take 200 volt and 50 hertz AC supply. Now we'll give pulses for the thyristors, and let us take the amplitude as 5, and the period can be 10%, but the period will be 1 divided by 50 hertz, and the pulse width, let us take it as 10, and the phase delay we can take it as 60 degrees, so 60 divided by 360 into the time period, which is 0.02 second. So to say this pulse will be given to the thyristors 3, T1 and T4. And for the other set of thyristors, we will be having the phase delay as 180 degree plus 60 degrees. So we'll be adding the time corresponding to the 180 degree, which is 0.01 to the existing angle. So this pulse will be given to the other set of two devices, T3 and T2. Now we'll be connecting the load. The load should be either RL or RLE or any DC motor load. So we'll be using RL load here. So take RLC series branch and change the branch type to be RL. Let us take the resistance to be 10 ohms and the inductance to be 20 millihenry. Then this load is connected across the first converter, and since the converter should be operated, only one converter should be operated at one time, we'll be connecting the load through a switch. So let us take ideal switch to connect the output of the first converter to the load. Now I will draw the second converter. And the second converter should be connected in anti-parallels to the load. And again, the second converter should also be connected with the help of a ideal switch. So we'll be connecting the switch between the second converter and the load. Now again, we need to give the gate pulse to the second converter switches. So we'll be giving the gate pulse to 5 and 8 with a firing angle of 60 degrees. And we'll be giving the other set of switches with a firing angle of 180 plus 60 degrees. Now we need to give the same AC input to the second converter. P terminal is connected to this point and N terminal is connected to this point. Now, in order to operate the first converter for first half duration, we need to give a gate pulse of a step. We need to give a gate. We need to connect the gate terminal of the idler switch to the step input. Let us take the initial value of the first step input as 1 and the final value as 0. The step time should be, let us take it as 0.1. that is half the time period of the period for which the first converter is to be operated. And similarly, for the second ideal switch, let us take the step time to be 0.1 as before, but the initial value which we are going to take it as 1 and the final value is 1. Initial value is taken as 0 and the final value is taken as 1, which means that the switch 1 will be operated during the 0 to 0.1 period. From 0.1 to the next half period, that is 0.2, will be operating the switch 2. So we can take the stop time as 0.2. So first half of the stop time, that is 0.1 second. For 0.1 second, the converter 1 will be connected to the load as the switch 1 is operated. And for the next 0.1 second, converter 2 will be connected to the load as the ideal switch 2 is now operated for the second interval. So now the circuit is ready. We can run this model by giving the power GUI. And we need to see the waveforms of the load voltage and current. So let us have a voltage measurement and current measurement. Then to see the waveforms, we can have scope. So we'll be connecting the load voltage and load current to the scope. And we can see the waveforms in the two axes. Now we can run this model. So we can change the y-axis minimum and maximum value as 300 minus 300 to plus 300. So we can find that the first waveform is nothing but the load voltage waveform. The second waveform is nothing but the load current waveform. For the first half of the interval, that is 0 to 0.1 second, the converter 1 is operated, so which will provide the first and the fourth quadrants of operation. And from 0.1 to 0.2 second, the converter 2 is operated, which is going to keep the third and the second quadrants of operation. So in the first and the fourth quadrant of operation, the voltage can be positive or negative. Current is always positive. In the second and the third quadrants of operation, voltage can be again positive or negative, but current is always negative. So this is how we can get the four quadrants of operation. By the converter 1 is now operated. Converter 1 and 2, they are now operated in the rectification mode with alpha less than 90 degree. We change the alpha value greater than 90 degree. Then both the converters will be operated in the inversion mode, so that we'll be having the next two quadrants of operation. Since converter 1 and 2 are operated in the rectification mode, with this we'll be getting the average output voltage of the converter 1 will be positive, and the average output voltage of the converter 2 is negative when operated in the rectification mode. When operated in the inversion mode, the average voltage of the converter 1 will be negative and the average voltage of the converter 2 will be positive, so that we'll be able to get the other two quadrants of operation. So in this simulation, in this video, We have seen the simulation of non-circulating current mode dual converter, and we have also seen the output voltage, that is load voltage, and the load current waveforms. Thank you.